Welcome to Video Assist. The lesson deals with frames of reference, and you can refer to Unit 1, Section B, Activity 5, and most specifically look at example number 2. In fact, read example number 2 first. In the frames of reference problems, students sometimes have trouble putting the diagram together. It's a vector diagram. They have trouble putting it together. The math isn't the problem. It's just how do I get my diagram? How do I figure out how it looks? This video hopefully will help you a bit with airplane type problems. With airplane problems, we have the formula, the vector formula, ground velocity equals air velocity plus wind. Now note that this is a vector formula. This is not a formula where if this was 2 and this was 3, then this would be 5. That is not necessarily the case. What this tells you is that you have to form and add vectors and form a triangle using this. So to show you here, well, let's just draw a triangle randomly. This does not relate yet to example number 2, but we're getting ready to do it. What this formula tells us is that we'll have 3 vectors. We have 3 sides, so we're ready to make them 3 vectors. And let's say that this is V air, and I'll just randomly choose it to be down. Okay, if this was V air, okay, then how would V wind have to be orientated to it? Well, it's being added. The rule for adding vectors is they have to be head to tail. So if I'm going to make V air down, then I have to make my V wind up. I'll sketch it in here. Then how does VG have to be orientated? Well, that is the answer when you add these 2 vectors. Okay, it's the sum of these 2 vectors, and it represents VG. But here's another thing that is helpful for students to recognize, that VG, because it is the sum or the resultant vector, it has to be head to head and tail to tail with the other 2 vectors. I'll repeat, head to head and tail to tail. So which way does VG have to go in this case? Well, if it has to be head to head, it has to go this way. That's VG going to the left, and now it's head to head and tail to tail. Now let's look at example number 2 and see if we can produce the diagram. Well, make sure you've read the specific diagram, but in this particular case it says that an airplane must fly northwest, north 20 degrees west. Okay, it must fly in this direction. So I'll draw a vector like this. Now if it must fly it, this vector relates to VG. Okay, VG is where you actually move, where the plane is actually going to fly. So this is VG. Now, one other trick to the problem is it says that this city is 550 kilometers away. Does that mean that this vector is 550 units long? No. All that it means is that this VG, that velocity, will take us in that direction, and we have to cover 550 kilometers. So I will put 550 down, but it is not the length of the vector, because 550 is a displacement. It isn't a velocity. The other thing that the problem tells us is that there is a wind blowing from the west. Okay, and it gives it to us in kilometers per hour, but I'm going to already convert it, and it happens to be 25.3 meters per second. Okay, I've converted that from kilometers per hour. And then finally it asks, what is the heading of the plane, or what direction should it point in order to fly in this actual direction? Heading is always associated with the air velocity. Okay, if you see the word heading, it's referring to its air velocity. So there's our 3rd vector. Remember, this is V wind, and it's asking us about the air, the heading. Now these 2 vectors have to form a triangle, and this is where students may struggle a bit. Well, remember that this is the resultant. This is VG. It has to be head to head and tail to tail with the other vectors. So I'm going to redraw it, and this is just forming the triangle now. This is VG. I do know that this is 20 degrees here. I'll put that in. Now, the V wind. The V wind has to be head to tail with V air, but it has to be head to head or tail to tail with this vector. It has to be head to head or tail to tail. Well, why not make it head to head? Because that makes a nice looking diagram. So that's 25.3. The reason I knew it went that way is because I had to either put it head to head or I have to put it down here, tail to tail. And I could also do that, but I prefer putting it head to head in this case. Now here's the third side. It's obviously right here. Which direction does that go? I know it has to be the V air. What direction would it go? Would it go up or down? Well, V air and V wind must be head to tail. So that means the head has to be here. So you formed your diagram. And the problem also tells us that this V air, it has an airspeed of 450 meters per second. So what we really have are two sides of the triangle, and you might say we don't have any angles, but yes we do, because this angle in here, right in here, is also 20 degrees, right, because of the Z pattern. And if that's a 90, that means that this whole angle inside here has to be 110. Now, refer back to the section online and take a look at example number 2. The math of showing how to solve it is there. I hope that helps you in putting together the triangle, which you always have to do when you're solving airplane problems and often boat problems. Good luck.